There are two modes in the spectrophotometer. One's called scan, one's called simple reads. Scan scans a sample with all different wavelengths of light and generates a graph that shows the relative absorbance each wavelength of light produces. We use scan for two reasons. The first is to find the wavelength at which the absorbance is highest, and this is lambda max. As you can see, it is the peak produced, and this can only occur between 390 and 800 nanometers of light because that's the wavelength of visible light. And then we plug this lambda max number, we go to a bit to the left, and we plug it into simple reads. We also do the scan to obtain a graph, and using the graph shape where the peaks are, we can determine what the compound is given in the reference, using reference graphs. So the quantitative data that scans gives us is lambda max. The qualitative data is a shape of the graph that can determine the mystery compound. We then use simple reads, which scans across only one wavelength, so it can only tell us absorbance values. And this only gives us quantitative data. So the Beer-Lambert law is A equals E times L times C, where A is absorbance, E is molar absorptivity, and L is length of path, and C is concentration. This simplifies down to A equals E times C because the length of the cuvette is 1 centimeter. Now, as you can see, we've drawn a calibration curve here. It is concentration as on the x-axis, the y-axis is absorbance. And the slope, it gives us the value of E, and that's the constant that we plug in here. So as you can see, there's a positive linear correlation between the concentration and absorbance, and this graph goes through the origin. Since the Beer-Lambert law does not have plus B is assumed to be 0, and that's why we zero the machine. We do this to give a standard for what the absorbance should look like at baseline. The blanking also allows the machine to have a saved absolute value of light at 0 to compare all the samples with.
Okay, so I'm just going to pour some of this into the cuvette. The cuvette, I want it to fill it to the line, as you can see right there. Alright, so as you can see, it's at the line. So that is our first cuvette.
He's going to confirm that the spectrophotometer has been zeroed. So now the spectrophotometer has been zeroed.
This is a blank solution, which is shown to be 0.0003. So first, Hemant is going to clearly wipe the two sides of the cuvette and make sure that they are clean. Next, he's going to place the clean cuvette into the spectrophotometer.
And then he's going to close the spectrophotometer with the clean cuvette inside.
And now let's start scanning the clean sample that I placed in the spectrophotometer. So now I record this 0.0281 in my lab notebook. Now Hemant is going to carefully remove the sample from the cuvette and close the door of the spectrophotometer.
Right, so as you can see, it's been filled up to the line, and this is what we're going to put into the spectrophotometer.
Right? Between the two sides that the light will pass through. That's what we're for.
Okay, so now we're going to place it into the spectrophotometer. Make sure it's firm. Now we're going to close it. And then we're going to click read. Wait for a second. So we're going to record it in the notebook. Now this is the stock solution, so it's going to be 0.02 moles. That's the concentration. So absorbance is 0.8480. We're going to take this out. So I'm going to open the door. Carefully remove the cuvette. Close it. And put it down.
And I filled it up to this line, transfer the stock solution into this cuvette, and we're ready to go. Open the spectrophotometer and place the clean sample inside with caution, and close the spectrophotometer.
Now let's come back here and make sure that this has truly been zeroed.
So now I'm going to place it in the spectrophotometer, but before I do that, I make sure that I wipe it and clean the sides of the cuvette carefully. And now I'm going to open the spectrophotometer and place the clean sample inside with caution and close the spectrophotometer. And now let's come back here. Now let's start scanning the clean sample that I placed in the spectrophotometer. The absorbance is 0.0281. So now I record this 0.0281. I'm going to carefully remove the sample from the spectrophotometer. And we are done.